Hello students, I am Rajesh Singh from CTP Bhatia Junior College of Science. I am sure you people must have solved the questions of set 1 which we have provided, and we are planning to provide 3 more sets of the same chapter, of course of the higher difficulty level. These questions are going to be useful for you as far as the preparation of boards and the entrance examination is concerned. Let us start solving 25 questions which we have provided you from topic Mechanical Properties of Fluids. Question number 1. The SI unit of shear stress is. Students, we know that stress is internal restoring force per unit area, that is force upon area. Hence, the unit of stress is Newton upon meter square, that is Newton per meter square, option A. Question number 2. 1 hectapascal. Students, hectapascal is unit of pressure and 1 hectapascal is 100 pascals. You have to remember this. Also remember, bar is also unit of pressure and 1 bar is 10 raised to 5 Newton per meter square. Question number 3. The only elastic modulus that applies to fluids is. Students, the right answer is bulk modulus, because fluids have fixed volume. They don't have fixed shape and size. Question number 4. The shear modulus of fluid is. As I mentioned, the liquids, they have only fixed volume, not the fixed shape. Shear modulus deals with regaining the shape of the body. Since they don't have a fixed shape, hence the answer is 0. Question number 5. The compressibility of water is 6 into 10 raised to minus 10 Newton inverse meter square. If 1 liter of water is subjected to pressure of 4 into 10 raised to 7 Newton per meter square, the decrease in its volume is. Students, bulk modulus B is given by formula pressure into volume upon change in volume. The compressibility is the reciprocal of bulk modulus. Hence, the change in volume of the water is compressibility into pressure into volume. If you substitute the values, the answer is 24 cubic centimeter. Question number 6. To what depth below the surface of sea should a rubber ball be taken so as to decrease its volume by 0.1%? Point number 1, students. Change in volume is mentioned is 0.1% of original volume. Hence, bulk strain, that is dV upon V, is 10 raised to minus 3. Point number 2, pressure due to liquid column. Now we all know that the atmospheric pressure is 76 centimeters of mercury column. My point is, how come pressure unit is given in centimeter? Centimeter is not the unit of pressure, students. It is the amount of pressure which 76 centimeters of mercury column going to exert, and that is given by formula H rho G, that is product of height, density of the liquid and acceleration due to gravity. Hence, bulk modulus B is pressure divided by bulk strain. If you substitute the values, the height comes out to be 90 meters. Question number 7. A swimmer is swimming in swimming pool at 6 meters below the surface of the water. The pressure on the swimmer due to water above will be. Now, as I mentioned, the pressure due to liquid column is the product of height of the column, density of the liquid and acceleration due to gravity, that is H rho G. Substituting the values, the answer is 5.88 into 10 raised to 5 Newton per meter square. Question number 8. A wire of length 50 centimeter and cross-sectional area of 1 millimeter square is extended by 1 millimeter. The required work will be. Now in 11th standard topic mechanical properties of solids, you people must have studied about strain energy or the amount of work done in stretching a wire. This work done is half force into extension. In terms of Young's modulus, the same work done can be written as half Young's modulus into area of cross section into extension square upon the original length. Substituting the values, the answer comes out to be 2 into 10 raised to minus 2 joules. Don't forget to convert all quantities into SI system before substituting. Question number 9. The isothermal bulk modulus of a gas at atmospheric pressure is. Students, you all are aware about Newton's formula for velocity of sound that we studied last year, in which one condition that we mentioned that in isothermal condition bulk modulus is nothing but pressure. Hence we can say bulk modulus is going to be the atmospheric pressure, and that is 1.013 into 10 raised to 5 Newton per meter square. Question number 10. A tangential force of 0.25 Newton is applied to a 5 centimeter cube to displace its upper surface with respect to the bottom surface. The shearing stress is. Shearing stress is internal restoring force per unit area, that is force upon area. And since it's a cube, the surface area of one face is its length square. Substituting the values, the answer is 100 Newton per meter square. Question number 11. A beaker of radius 15 centimeter is filled with liquid of surface tension 0.075 Newton per meter. Force across the imaginary diameter on the surface of the liquid is. Here we are coming across a physical quantity called surface tension. Because of this physical quantity, liquid tries to contract and keeps its surface area as small as possible. That's the reason why liquid drops are spherical in shape, since sphere has the minimum surface area. This quantity surface tension is the force acting per unit length. That is, surface tension T is given by force upon length. The question is talking about the imaginary diameter. That means the length of the line is 2 times R. Force F is surface tension into length in contact. That is T times 2 times R. Substituting the values, the answer is 2.25 into 10 raised to minus 2 Newton. Question number 12. Cohesive force is experienced between. Cohesive force is the molecular force which acts between the molecules of same substance. Hence the answer is C. The other type is called adhesive force, which is the molecular force between the molecules of different substance. Question number 13. SI unit of bulk modulus. Now we know bulk modulus is pressure into original volume upon change in volume. Hence, SI unit of bulk modulus is same as that of pressure. That is Newton per meter square. Question number 14. Pressure is a scalar or a vector quantity? We all know pressure is force acting per unit area. But to change the pressure, force has to be applied from all possible directions. Since there is no fixed direction, hence pressure is a scalar quantity. Question number 15. Which is the most elastic material? Students, elasticity is the property due to which a material body opposes the deforming force and regains its original shape and size once the deforming force is removed. The material which can provide more opposition to deforming force or can recover original dimension from larger deforming force will be the most elastic material. Out of the 4 options, the right answer is C, that's quartz. Question number 16. If the excess pressure inside a water drop is 80 Newton per meter square, then the diameter of water drop is given surface tension is 7.27 into 10 raised to minus 2 Newton per meter. Now students, we just now discussed about a physical quantity called surface tension, due to which the liquid tries to contract its surface area. Due to this contraction, there is excess pressure inside. Imagine a liquid drop which is spherical in shape, which is trying to contract its surface area, then the pressure inside is going to be more than the pressure outside. This difference in pressure is called excess pressure, and this excess pressure in case of a liquid drop, that is P inside minus P outside, is 2T upon R, where T is surface tension of the liquid and R is radius of the drop. Substituting the values, the diameter comes out to be 3.6 millimeter. Question number 17. According to Hooke's law, force is directly proportional to. Now we have studied Hooke's law in 11th standard, topic mechanical properties of solids. It says that within the elastic limit, stress is directly proportional to strain. We can say stress upon strain is a constant. And if I'm talking about this modulus of elasticity, that is Young's modulus, Y, it comes out to be force into original length upon area of cross section into extension. From this formula, it is very clear that force is directly proportional to extension. The answer is C. Question number 18. In solids, interatomic forces are. Interatomic forces are the forces which are developed due to charge on the atoms. Hence, these forces are either totally repulsive or totally attractive, depending upon whether they are like charges or unlike charges. Hence, the correct answer is D. It is a combination of A and B. Question number 19. A spherical drop of water has a radius 1 millimeter. If the surface tension of water is 17 to 10 raised to minus 3 Newton per meter, difference of pressure inside and outside of the drop is. Now students, just now we talked about the excess pressure inside a liquid drop. That is P inside minus P outside. It is 2T upon R, where T is surface tension and R is the radius of the drop. Substituting the values, the answer is 140 Newton per meter square. Question number 20. The pressure on a swimmer 20 meter below the surface of water of sea level is. Now just now we discussed pressure due to liquid column. It is the product of height, density of the liquid and acceleration due to gravity. If you are substituting the values, the answer is 2 into 10 raised to 5 Newton per meter square. That is 2 times the atmospheric pressure. So we can say that total pressure on the swimmer is atmospheric pressure plus the pressure due to liquid column. The answer is 3 times the atmospheric pressure. Gauge pressure at depth h below the liquid surface can be written as. Students, the difference between the absolute pressure and the atmospheric pressure at any point is called the gauge pressure. That is P minus P0. The gauge pressure is the product of height of the liquid column, density of the liquid, and acceleration due to gravity. For further details, you can refer page number 30 of the new government textbook of Standard 12th. Question number 22. Two capillary tubes of radius 0.2 cm and 0.4 cm are dipped in the same liquid. The ratio of heights through which the liquid rises in the tube. Now the question is basically talking about a capillary action. So let us first discuss what is capillary action. Students, if you take a small capillary tube and dip it in the water, then you'll find that the liquid surface of the water inside the capillary is concave. You must have noticed this while performing titration experiment. The liquid inside the burette and the liquid surface inside the pipette, you must have noticed it is concave in shape. Now since it is concave in shape, the pressure towards the concave side is always greater, and this is because of surface tension. Now due to this difference in pressure, the liquid level inside the capillary rises or falls down depending upon the density of the liquid. This phenomena is called capillary action. You can refer page number 42 of new government textbook and get the details of capillary action. The height through which the liquid level rises or falls down is given by 2 times surface tension into cos of theta upon radius of the capillary tube, density of the liquid, and acceleration due to gravity. Here, T is surface tension, theta is angle of contact, R is the radius of the capillary tube, rho is density, and G is acceleration due to gravity. From the formula, it is very clear that H is inversely proportional to R. Hence, in this question, H1 upon H2 is going to be 2:1. Question number 23. Oil rises up in the wick of lamp due to. Now just now we discussed the rise or the fall in the liquid level in the small bowls is called capillary action. It is also known as capillarity. Question number 24. If the surface tension of water is 0.06 Newton per meter, then the capillary rises in the tube of diameter 1 millimeter is. Angle of contact theta is given as 0 degrees. Density is 1000 kilogram per meter cube. And acceleration due to gravity is 10 meter per second square. Now, as we discussed in question number 22, the formula for the rise or fall in liquid level, that is the height through which the liquid level rises or falls, is given by 2t cos theta upon r rho g. If you substitute the value, students, the answer comes out to be 24 centimeter. Question number 25. L0 m1 t minus 2 is dimension of. Now students, whenever you are solving question based on dimensions, I always recommend that you learn dimensions of force, work, and charge. If you remember these three dimensions, you can quickly and very easily find out dimension of any physical quantity. Now coming on to the question. We know that dimension of force is L1 m1 t minus 2. Hence, the given dimension, that is L0 m1 t minus 2, is the dimension of force upon length, and force upon length is the formula for surface tension. So these were the solutions of the questions that we have provided in set 1. I hope you people have followed it. In case if you have not, then we would like you all to send your queries and doubts in the comment section. Thank you very much.